So in this video I want to talk about generics in TypeScript, and in the previous video we sort of set this up. We got our index boilerplate up, HTML with this script index.js, we got our compiler, and we also did a TSC -init, and we got this TypeScript file, and that's used so we can go use the TSC-W to watch all our TypeScript files, and then when we make a change, it will output those changes in JavaScript files. So definitely check out some previous videos on TypeScript if you're not sure, how the compiler works and all that stuff. These generics can be a little tricky, but I'll do my best to make it as simple as possible. So the hello world of generics is having like an identity function. So this is like a function that will return whatever we give to it. So let's say we have a function, and we might think that we would create it like we take whatever the argument is of the function, and we might think, okay, if we return any, we can take any type and return any type, and we can return that arg, and that will sort of work, and it will return it, but we're losing. We've seen with any keyword that we lose out on a lot of the benefits. So like, for example, if I say let x equal this identity, we pass in, say, string 1. Now we don't know the type of that, and since the type is lost, that means all of the methods and string methods like to uppercase and all that stuff, we don't get that IntelliSense and anything like that, and it's not good for type checking either if we pass that property around our code base. So what the solution to this problem is a generic, and what a generic will do, it will allow us to keep that sort of information that was lost when we return the type. So we'll know the type that we're returning to, but we can return any sort of the types passed to it. So any is generic, but we're losing out on those benefits. So what we need to do is we need to capture the type of the argument and use it to denote what is being returned. And the way we do this in TypeScript is we have this type variable t. So what we can do is, we can say that our identity function, rather than taking in any type, it takes a t, and it will return any type t. And note that this still hasn't worked for us yet. So with the sort of primitive types and the simple types, the function behind the scenes, it infers that it needs that type. So we pass in Boolean, the function already knows it needs the Boolean type. But for this t type, the type variable, it's a variable type. So we need to sort of tell TypeScript that we are passing in a variable type explicitly. So that's why we need to use these angled brackets and explicitly say t. So what this will do is we'll take an argument of any type and it will return that argument with that type, rather than the any type. So what we can say is this version of the identity function is generic because it works over a range of types. And just to look at this angled bracket t again, this means that the function declare is going to use the generic type, and that's done through this sort of type assertion. So either in the arguments that it's going to take in, or the return type, and that's what happens. So if either this or this has a variable type, then we need to put it in the function declare through type assertion. Okay, that's cool. So there's two ways that we can call that function, and the first way, and is probably the most common way, is to say, okay, let x equal identity string, and that's just, that's the more common way, and it's through type argument inference. So we've seen TypeScript's ability to use type inference, and this is just type inference on the argument. So the compiler sets the value of the t variable type. Now, for example, if we say x dot, now we have all the string methods like split, substring, search, and we can say, okay, so that's the string, and if we said let x equal identity of 5, so it took a string before, now it takes a number, now we should get all the numbers, so to exponential, to fix, etc. So that's the power of the variable type and where generics sort of come in handy. Now, the second way we can call a generic function is we can sort of say let x equal this identity function, and we can sort of have our we can sort of pass the type argument to the function directly, sort of thing. So we can say that this is going to be of the string type, and then we might have string. So I do think this makes it a little unnecessary and verbose for the case that you're dealing with all the core, strings, booleans, all that stuff. But it's something to keep in mind when we start, creating our own types and having more complicated functions, that, okay, the compiler might fail to infer the type, and then we will have to explicitly type in the type through this sort of type assertion. So I might just leave that there like that. Okay, so let's see an example. Let's say we wanted to, and I might just copy this. Let's say we wanted to return the type, but we also wanted to log the passed variable as well. So we can call this the logging identity. And once again, we need to tell TypeScript that we're going to use this t variable, like a variable type, so we can use it in either the argument or the return type. And we're just going to add one extra thing here, where we want to console.log whatever argument got passed, the length of that. So something to notice is the length fails, and the length fails because not every type has a length. For example, an array will have a length, and a string will have a length, but perhaps a number does not have a length, so it doesn't make sense for that particular type to be able to log that. So TypeScript points that out for us. So that's good. But let's say that this wasn't intended for any type, but for an array, a length of of whatever the arrays are. So what we can do is we can say, what we can do is we can say, we can let the argument here be of an array type, and we want to return the same thing, so we can pass that there like that as the return type. And every array sort of has a length, so now this length property can be applied to the generic type. Another way we can sort of write this is we can also have this array with the generic type sort of syntax like that. And that's just another way to achieve the same goal. And the way we can read this sort of function is we can say that, okay, the generic function, so when we see this here, we know that we're going to use the variable type either here or in here. The generic function, so this function is generic. The generic function logging identity takes a parameter t and returns an argument. Okay, so this generic function logging identity takes a type parameter t and an argument which is an array of t's, and returns an array of t's. If we pass an array of numbers in, t will bind to number. So if we had like an array 1, 2, 3, 4, we pass that in, the type will bind to number. And notice that this, where we sort of, this just tells TypeScript that either the, it just says to the core signature, so the arguments and the return type, that the core signature will have this variable type. It doesn't have to be of the array type, and that's because it's telling the function declare will use that generic type rather than explicitly saying anything more than that, like an array of. It's because it's not a return type, it's not an argument type. It's just telling the function that okay, core signature is going to have that type. So it can't be sort of inferred by like the same way more simpler primitive types can. And okay, and all arrays have a length, so this error is no longer an error. Okay, so what we can do now is we can take a look at the type of generic functions. So let's go back to this simple example here. So we're taking a look at this function identity. So the type of generic functions is similar to the non-generic functions, with the type parameters listed first. So for example, let's say let my identity, so this is the key difference here, is saying that we have this variable type associated with the core signature. And so then we can just write the core signature as usual. So it takes an argument of the variable type t, and that returns a type t, and let's just say that that equals identity. So what we've just said here is, if we want to give this function a generic function type, we know that the function is going to use the variable type, hence we need to sort of say that it will with this sort of type assertion syntax with the these sort of brackets here. And then just like in a regular function where we might have an argument, and say t represents a string and it returns a string, normally we'll just have something like this, but we've just changed the type to be generic, so we can take any type like boolean, string, and so on. And the one extra step when making a type for the generic is using this sort of assertion to let the function know that that variable type will be used. And then we can sort of assign this, we can assign this variable, my identity, which has that type, to this generic function. So we can also write the generic type as a core signature of an object literal. So that's sort of what's going on in there. But to extend that idea, we can sort of use it in an interface, let's say. So let's go ahead and comment this out. So yeah, we'll talk about generic interfaces. And okay, so if you haven't seen interfaces, check out my previous video on interfaces. But let's say we have this interface of a generic identity function. So we can just pretty much copy this whole core signature here. So where the function's core signature is composed of the arguments it takes and the return type, and since we're using a variable type, we need this one extra step where we assert that function to include that type, and then we use t to represent the variable type. So that's the generic identity function interface. So let's use that interface, and we can say that, okay, let my identity, so rather than using the object literal style, we can use it through the interface, or we can use that the other way around. What we can do is we can say, let my identity, one word, be of that type, or that interface, generic identity function equals identity. So we've more or less done the same thing here. We've just sort of given, rather than this sort of explicit sort of rather than writing it in line, we've sort of assigned this generic identity function, this core signature type, to its own interface, so we can use that interface for the my identity, and that's what we've assigned to the identity function. So that's a generic identity function in action, and that's demonstrating the generic interfaces being used. I suppose we can see that in action by calling it. So my identity, and let's say we have the word string, so that's all good. And if we use some IntelliSense, we get all the string methods like before. And if we did the same thing but for a number, and then we use the IntelliSense, we can see, okay, what's happened is we define this interface that can take any argument type, returns any argument type. So we let the function know that's using it that it can take that variable type. Then what we've done is we've assigned this variable, my identity, to take the shape of this interface, like this object, so the notation, and which is the function. And since that variable will take the shape of that function, that means the function is, you know, pointing towards or referencing needs to conform to that shape. So that identity function does definitely conform to that shape there. So we'll return that, and that means we do get all the IntelliSense that we would expect, and type safety. So, okay, actually, before I delete that, I just want to pass in something else. So let's say that I passed in a string and a number, and okay, so what's going on here? What this is saying is, because we've passed in an array of the string and number type, you know, that's what we're expecting as a result, but we may want to, and that's what our sort of interface is allowed for, but we may want to restrict that to being just an array of strings or just an array of numbers. So we want to restrict it to one certain type. So we still want to put in anything, but we want to restrict it. So how could we do that? We sort of need to make the type parameter visible to all of the other members of the interface. So we need to lock in the type that the underlying core signature will use. So in our interface, where we define it, rather than putting the core signature, the type in the core signature, we can put it in the interface itself. And why we're putting it in the interface in this case is we want to have that consistent type. So now we notice that we do get this error pointed out because it requires one type argument. So we're implementing that interface, and the interface is expected to be of a certain type and only one type. So that's the key distinction between putting the variable type on the generic identity function interface versus putting it on the core signature. So now to say my identity, what we'll need to do, let's say we want a number of arrays, we need to sort of tell TypeScript that we want a number passed into that interface, meaning that now the error is here. But if we set 1, 2, 3 like that, okay, this still is erroring. And for good reason, because this is not a number, this is an array of numbers. So we could say, give this the type array of numbers, or what we could do as well is we could say, so rather than having this like nested angled brackets, we could have number array in this sort of format. So then if we put in some random string, we get an error there, and TypeScript points that out for us because it's now enforcing the type as well through the interface, which we explicitly write through type assertion of the type variable. Okay, so that's what I wanted to discuss there. Now the next thing to to discuss is generic classes. So generic classes, you know, they're a similar sort of shape to a generic interface, but they also have generic type parameter lists. So we'll see that in a minute. And the parameter list, the generic type parameter list, is in the single angled brackets following the name of the class. So let's just write that class. Let's say we have generic number, and then that has the variable type there. So we've said that this class is now generic. And the latest versions of TypeScript include strict class checking. So that means all properties need to be declared in the constructor. So for example, if I have, say, 0 value equals to a type, add equals to a type, because we want to add a, this could be referring to like a number, but we might do something later that refers to a string. So let's just do a number first, so generic number. So if we add this, if we make an add, if we make an add function, we can give it the core signature with x as a random type and y as a random type. And this is more an example to see generics in a class rather than this particular example itself. But note that in the new TypeScripts, we get this error saying the property 0 value has no initializer and is not definitely assigned in the constructor. So to alleviate that, we can use the bang symbol. So let's use the bang symbol, so the exclamation mark on the shift 1, and now we no longer have to write that in the constructor. And I've done that for a reason, and that's because I want to demonstrate the class, generic class, as easy as possible. So let's say we let my generic number be an instance of that class by using the new keyword and generic number, and then we sort of assert that it will be of the number type, and we do that assertion just before the parentheses, which signifies that we're calling that class. So now with this we can say, okay, my generic number. So I didn't want to initialize it in the constructor, I sort of wanted to do it after I've instantiated the object. So if I type in 0 value, I can set 0 equal to 0, and I can set add equal to a function x and y, which will return x plus y. So that's cool. So let's do the same thing, but with a string. So let's say we had a string numeric, and okay, let's see here. Yep. Let's just copy this down here, and we'll change the word generic to we'll change it to string, and let's change this to let's see here. Well, I want it to be the same as this class. Perhaps the class generic number doesn't make as much sense now that I'm doing it for a string. Perhaps I should rename the class to generic add. Okay. I mean, it still has 0 on it as well, but it's just slightly more descriptive. Generic add. So generic add, it will take any type. The class will take any type, and it will have a 0 value associated with it, and it will have an add function associated with it. So if I make a generic number class, I can instantiate that in the regular way you instantiate an object, but by having this type assertion to pass the variable number type into that class. Thus we can do something specific for that case that it is a number, and we can say, okay, if it's a number, we can sort of, after we instantiate it that it is a number, on that instance we can assign the 0 value property equal to 0, and we can add, assign the function add to be, just adding the two numbers. And the reason this is generic, the class is generic now, is because if we instantiate that same class, but we pass in, let's say, a string instead, and this probably should say my generic string rather than that, so I might just copy the word generic, paste it in here, delete the word number, and okay, so this time so since we passed in a string now, the 0 value is expecting a string in return, so that's good that we got that error, and TypeScript points that out to us. So the 0 value for a string is just an empty string, and adding the function can be the same, just concatenating the two functions, but this time it's not adding numbers, it's sort of adding strings together. So yeah, we can see the use and sort of the power of generics, and this is an example of a generic class. So yeah, I won't actually console log that, but you can see that working out. And finally, suppose, or not finally, we'll do two more things. So the second last thing we'll talk about is generic constraints, and we'd like to constrain this function to only work with types that have the length property. So the function I'm referring to is this logging identity function. So recall that we whatever we pass to it, we had to pass an array to of that type to be able to capture the length. But rather than, what if we didn't want to capture the length of an array, we wanted to capture it of a string, or could be an array, but it might not be an array, it might just be a string or something like that. We don't want to limit ourselves to only logging identity, the length of whatever type variable got passed in to an array. So so recall that the length does not exist on type T for all its cases. So a number might not have a length, for example. But what we can do is we can create an interface that has the length property. So let's say we have an interface and we call it lengthwise, and this has a property length. Now if we sort of we take this function here and we can say that okay, it's still going to take any type, it's still going to return any type, but you know, the type that the function will be using, so the type that the function, the core signature will use, it's going to extend that lengthwise interface. So what that's saying is, okay, so what we're doing there is we're sort of constraining the generic function, so it will no longer work over all the types, but it will work on all the types that extend which have the length property associated with them. So for example, if we call that identity function on 5, we're going to get an error because 5 doesn't have a length. But if we call that logging identity function, the generic function, on a string, let's say string, then it does work. And we can sort of it sort of filters out all the types that don't have the ability to have a length. So the variable type t, it must extend this lengthwise interface, meaning that whatever variable it has, whatever variable we pass into it, must have this length property. And if it doesn't have a length property, then that variable type sort of isn't of consideration, and it won't be acceptable by the function. So that's an example of constraining generic constraints and constraining our the types and all that stuff. So okay, but yeah, I suppose what we should finish up on is using the type parameters in generic constraints. Okay, so let's just comment this out, continue on. So you can declare a type parameter that is constrained by another type parameter. So to get a property from an object given in its name, ensuring a property not existing on the object is used, place a constraint between the two types. Okay, so let's sort of make sense of this. So a function, let's say we have a function, and what it's going to do is it's going to get the, so say we have an object and we have we can pass in, say, yeah, we have a function and we can pass in an object, but we can also pass in a key, and then we want to know if the key is in the object. So let's just go ahead and make that. So we'll have this function get property, and that's going to, that'll do something. And what it's going to do is it's going to take a variable x. So let's just make that. So let x equal an object. So a equals 1, b is assigned to 2, c is assigned to 3, d is assigned to 4. So we've got an object. And what we want to do is we want to say, we want to call this get prop function. And what we want to do is we want to pass in that variable, that object, and then we want to see if the key has a value. So we're expecting a to be in there, and then if we call another function, say m, we're expecting that not to be in there. Okay, so let's go ahead and implement that. And the way we can do that firstly is to say, okay, so we're going to have an object. An object can be of any type, So let's say we have an object key, and we can have a key. So the key, you know, that doesn't necessarily have to be, you know, a string. That could be a number key or something like that. So we can use this other sort of variable type, and we can say, okay, that variable type can be k to represent the key. So one thing to note is that when we're using these variable types, we have to tell the function that we're using those. So we're expecting, as before, that we need t, but now we also need the variable type k. So the variable type k, what is k? Well, k represents the key of the object. So let's say we have this object here, and in this case, the key is either A or B or C, and but notice that these keys, they're contained within the actual object itself. So remember, the object itself is representing the type, or the variable type, but we just want the keys of that variable type. So what we can do is we can say that k, it actually extends the key of t, meaning whatever the type is, whatever that object is, the keys of that object are being assigned to another variable type k that must sort of be constrained to extending these keys of that variable type object. So notice now we immediately get an error on the m, and that's because m is not assignable to the parameter type A, B, C, or D, because that's, you know, m is not a key. So let's just go ahead and implement the details of this, and we can just return whatever the object is, and we want to return the key. So what we're saying is that, just to recap over this sort of you know, this function here, what we're saying is, okay, we want a function getProp, and what we want to do is we want to return the key of the object. But the object could be of any type, and the key could also be of any type, meaning, you know, it could be a number, it could be a string, etc. So yeah, so for whatever type we've been given, so we've got this object here, whatever object we have that could be of any type, we need to access that object's value by the key. So for example, if we want 1, we can say, okay, x of a, so the key will be a, x of a, that will return 1. So whatever the object is and its key that we're looking for, we can get that property. So that's the implementation logic, and the TypeScript sort of shape of this is, okay, for whatever type t you have, for whatever type you have of key, okay, so we know that we need to pass in the t variable and the k variable, because we know that we need the type variables the function needs to be able to identify that we need those type variables, because T and K are used in the core signature, in particular in this arguments. But K can be more descriptive in the sense that, okay, the whole thing is the type T. We only need the key of that type T. So K, representing the keys, must extend the key of T. And then we can see that in action when we call the get property. We know that the key A is in the object, but we know that M is not. And that's sort of, another way we can use constraints between two types. So, you can declare the type of the parameter that is constrained by another type of the parameter. So this is a type parameter, and this is another type parameter that is constrained by this type parameter. Okay, so that's what I wanted to talk about on constraints. So just to recap what we covered here, we went over generics, and we did the identity example, the hello world of generics, and we've seen that we can pass in to a function different variable types, and depending on the variable types we pass in, we may get a different response, or we can call a function in that sort of way so we can obtain what we want. And then we had a look at the sort of syntax of the core signature and why we need to explicitly have the T here and what the T means. And then we had a look at generic interfaces and applying those generic interfaces and applying and using generic classes, and then some instantiation of the class, and explicitly typing in the type to the class to get different sort of properties or methods sort of set on that instance of the class. And then we had a look at how we can sort of filter out unneeded types, and that's done by extending an interface which contains a type that we need. But we also looked at sort of constraining it in another way by extending the keys type. So yeah, that's generics. In the next video we'll take a look at some we'll take a look at modules and namespaces. Okay, so thanks so much for watching, and yeah, give it a like. Cheers.